So planning experiment question. Okay, question 10, which is about investigating whether a diameter of a pendulum bob affects the period of pendulum. What is the period of a pendulum? Means time it will take to complete one oscillation, that is called a time period or a period of a pendulum. Figure 3.2 shows one complete oscillation. What is the meaning of one complete oscillation? Like example, if we release from this point, it will go one end and then return back. That is one complete oscillation. Or we release from here and then it returned back. That is also one oscillation. So this is the time for one oscillation. We have the clamp, stand, thread, bob is there. Student has the following apparatus: a pendulum bob made up of polystyrene with a diameter of 1, 2, 3, 4, and 5 centimeters. A supply of a thread and a pair of scissors are there. Like we have a thread and a scissor just to cut a certain length. We have a clamp and stand to hang this pendulum. Plan an experiment to investigate whether a diameter of a pendulum bob affects the period. You are not supposed to say it will affect or it will not affect. You just have to plan the experiment. You're not supposed to conclude anything. List additional apparatus that you would require. What else? What we need? What is missing here? A very important apparatus. Stopwatch. So what is missing here? The missing is a stopwatch. So stopwatch or a stop clock, you can mention. Stopwatch is the right term. Explain how would you carry out this investigation? How we'll do this experiment? If you want to plan this experiment, so whenever you want to determine the time period of oscillation, first thing, like because we have the scissor, we have the thread available, and we have the box. First, we have to set up. And like example, measure even a meter rule. I think meter rule is not mentioned, so you can mention additional apparatus. You can mention stopwatch and a meter. Or a meter scale. Then first thing what we will do, we will measure like 30 centimeter, 50 centimeter, 30 centimeters, right? 50 centimeters also correct. Like measure 30 centimeter length of pendulum. And clamp with a bob of 1 centimeter dia, like and clamp. Then mark the mean position or extreme position or mark the fiducial points. Mean position is a center position and extreme position where we'll displace. But this displacement, keep in mind whenever you're doing this experiment, the displacement should be very small because the formula which is derived to get the time period of a pendulum is based on assumption that the angle which we displace the pendulum is very small. So measure the mean position and extreme position or mark mean position and extreme position, and the displacement should be small. Then we'll reset the stopwatch. Then we'll record the time for 20 oscillation or 30 oscillation. And then the time period will be the time which we record, example, small t divided by number of oscillations. Then we'll repeat with 2 centimeter diameter bob, the 3 centimeter, 4 centimeter, and 5 centimeter. So we repeat with different size of bobs. So this was the first part we did, and this how we carry out the investigation. State the key variables that you would control. What are the variables we should control? Length of pendulum, that's right. What else? Displacement or amplitude. So the variables we should control. The length of the pendulum, the amplitude, the number of oscillation, that's right. It's the same material, so polystyrene is there, so definitely because the material is not changed, so density will be same. So amplitude you can mention, length you can mention, surrounding wind, because wind can also affect the air current, can also affect the time period. Amplitude is refers to a distance from mean position to extreme position. Like the center position of a pendulum to the extreme position when we displace, that is called amplitude. So variable length, amplitude, the shape of the pendulum's shape of the bob should be same, because we are just investigating how the size is affecting. The shape should be same for all. Yeah, greater, because the density is constant. So if you are using a greater diameter, means it will have a greater mass as well. So it's obvious thing, because it's made, all are made up of polystyrene. So if all are made up of polystyrene, all have the same density. Density is mass over volume. So mass multiplied by mass is equals to density time volume. So if you use a large volume, we'll have the more mass. It's obvious thing. Draw a table with a column heading. So how the table will look like? Table with a column heading. So yeah, so this will be a diameter. Diameter is in centimeters. Example, diameter is denoted by D. Whenever you complete a table, it should be with a column heading, like the unit. So diameter is in centimeter. Then small t is a time for 20 oscillation, and capital T is a time for one oscillation, like which is a time period. And diameter, because you know diameter, so you can write the values here, but you're not supposed to write any value. Even if you don't write these diameter value, that's fine. But as we know that we are having a diameter 1, 2, 3, 4, 5, so we can write these values. How would you use your readings to reach a conclusion? How we reach a conclusion? So which graph I should plot? So I should plot a graph between the diameter and the time period. So if our diameter is on x-axis and the time period is on y-axis, so we can just plot a graph between diameter and time period and compare the relation, like whether proportional, inversely, linear, non-linear, any relation they can have. You're not supposed to draw any graph. You just have to mention, use the readings, plot a graph between the diameter and the time period. Usually selection of the axis, look, selection of the axis, there is a standard rule. You can choose any, but there is a rule for selecting the axis. The rule is that the independent variable, the variable which does not depend on the other factor, that should be on x-axis according to experiment. And the dependent variable should be on the y-axis. That's a rule. So what you're doing, you're changing a diameter and you're finding whether time changes or no. So if I change the diameter, the time will change. So means what is diameter? Dependent or independent? Independent. So diameter is not depending on the, if I change, I'm changing diameter and the time period will change. So that's why the time period I plotted on y-axis and the diameter was there on x-axis. So in this experiment, the time period depends on the diameter. That is what we are finding. So we are changing a diameter, and we are finding whether a time period is affected or no. So time period depends on a diameter in this case. That's why we are plotting on the y-axis. But if you draw other way around, because the mark is not the selecting the axis, the mark is like plotting a graph between the which quantities. That's why if you just mention plot a graph between time period and diameter, any one of them x-axis or a y-axis, you will score the marks.